All right, calculus folks. Here's a video on section 4.2, which is Rolles theorem and mean value theorem. So Rolles theorem is what we're going to talk about first. It is based off of, it was created by Michel Rolles. I'll show you what this guy looks like. Hold on. Yeah, check this out. Here he is. He's French. 1652 to 1719. He was a French mathematician, master of extrema. He was a hopeless romantic, supporter of male perms. Check out that hairdo. And an all-around good guy. And ironically, he was an early vocal antagonist of calculus, which means he was actually like anti-calculus. He said calculus is bad when it first started. And the irony is his theorem is used in this stuff we're about to do in calculus, which is kind of funny. He had a cool hairdo. But anyway, his name was Michel, my consigliere. So first of all, Rolles' theorem says if f, your function f, is continuous. Remember when we talked about continuous and discontinuities earlier? On AB, on the interval a to b, and it's differentiable, which is like another word for you can take the derivative of it, on a to b without including the endpoints. See, I wrote them with parentheses, not brackets. And you say if, so you start off with the first if. First of all, you have to be continuous and differentiable on that interval, not including the endpoints for differentiable. If your f of a equals your f of b, then there exists at least one number C on your interval where the derivative evaluated at C equals 0, which is a really fancy way of saying if you start at the same height, let's turn this into more plain language, but you should be able to read the math language too. This one's written in Mathlish, we're going to write it in English. If you start and end at the same height, there must be at least one max or min in between those points, in between your endpoints. Okay, so, and that's why it's important you're continuous and differentiable, because otherwise you're going to have asymptotes. If you weren't differentiable, you'd be able to have asymptotes, and then you wouldn't have max or mins. If you weren't continuous, you could have a graph that jumped. You'd be like, okay, I'm starting at this height, and doing that, and then I'm going to go from here, and go down forever. Then I don't have a max or a min, and, it would be differentiable on all these parts, but it would have a gap. So anyway, weird stuff, weirdness going on there. So long story short, if you're continuous and differentiable, which means you have a pretty normal graph that you can draw without picking up your pencil, and you start and end at the same height, then there exists at least one point on there where you would have the derivative equals 0, which is where max and mins occur. That's called a critical number, right? So just think of drawing it, right? If I start and end at the same height, I want to get from here to here. Here's A, here's B. Then I could go like up and down. Well, I got a max, right? Like, wait a second, why don't you just go, wiggly wiggly, right? Well, there I got a min, a relative max, a relative min. You could just go all day with those, right? You could go all the way down. Got a clamshell. Looks like somebody's logo. Pistachio. Anyway, so yeah, you have to have either a max or a min, or you could have multiple of them in between. And that's what the derivative equaling 0 is. So that's what Rolles' theorem says. So what we can do now that this is a theorem, so he actually proved it. He's like, okay, I guarantee there must be a relative min or relative max between A and B if I have a pretty normal equation. So let's look at an example. Okay, look at f of x equals x squared minus 3x minus 4 on the interval from -1 to 4. Okay, so we're going to look at this graph on a chunk. Okay, we want to find all values of c such that, I'm going to shorten such that to st, f prime of c equals 0. So I'm basically looking for when the derivative equals 0, also known as max or min places, right? So one thing we have to do, this is a Rolles theorem problem. One thing we have to do is we have to first check that the endpoints are the same height. Okay, so I want to check, here's my start, right? And here's my end x. So I want to check that f of -1 really is the same number as f of 4. Does it start at the same height and end at the same height? So if I plug in a -1 to my original equation, okay, I'm going to do 1 squared minus 3 times -1, so that's 4 minus 4, so I got 0. If I plug in a 4, I got 4 squared is 16, minus 3 times 4, so minus 12, minus 4 is 0. So check, that checks out. Those are the same height. So it starts and ends at the same height. Now I want to find f prime of x and set it to 0. Okay, so that was my first step, was to see if it starts and ends. The next step is find all the places where the derivative equals 0. So first, take the derivative. That's an easy one, right? 2x minus 3. Now I set it to 0. Sometimes these will be harder equations, but this one's pretty easy, right? So x is 3 over 2, or x is 1.5. Now I want to make sure, last step, make sure that is on the interval from -1 to 4. It's 1.5 between those numbers. Yep, there's my winner. That's where a max or a min would be, right there at 1.5. All right, so that was our first example. I'll come back for another video with another Rolles theorem, and then we'll try out the mean value theorem, which is pretty related. All right, so it's also common sense. I mean, if you start at the same height and end at the same height and have to draw a line without picking up your pencil, you're either going to go up or down, or if I go straight across, is there a max? Yeah, every point is the max height, or every point is the minimum height. So anyway, that's kind of the weirdest case, is a straight across the line, but you would have an infinite amount of max and mins. All right, so hope that made sense. I'll come back with a secondary video where we do that and do mean value theorem, and I'll let you, have one more view of this sweet looking perm. All right, later, people.